What if you woke up one day and found that Earth was completely frozen? No sunlight, no life, just an endless icy wasteland. Sounds like science fiction, but this actually happened. Around 650 million years ago, Earth turned into a giant frozen sphere, an event now known as Snowball Earth. What caused our planet to plunge into such extreme conditions? And, more importantly, how did it manage to escape? Join me as we unravel the epic story of one of the greatest natural disasters in Earth's history. Snowball Earth was a defining moment in the planet's history. A catastrophic freeze that nearly wiped out life, only to ignite an evolutionary leap that led to the complex creatures we see today, including ourselves. But as life adapted and evolved through Earth's ever-changing conditions, it faced challenges that would have made human survival impossible. This begs the question, if we could travel back in time, how far into Earth's history could we have survived? The capsule shudders as the temporal engines slow, jolting the traveler from their anxious thoughts. The whirring hum of the time machine reaches a crescendo before abruptly cutting out, leaving only the sound of the traveler's own breathing in the recycled air of the pod. The digital readout on the screen flashes 4,500,000,000 years ago. They have arrived at the very beginning of Earth's history, a world so alien that it hardly resembles the home they know. Tentatively, the traveler peers through the curved glass windows, half expecting to see a familiar, albeit primitive, version of Earth. Instead, they are greeted by a vast, searing void. The sun, a younger, hotter version of the star they had just left behind, blazes fiercely in a black sky, unsoftened by any atmosphere. The Earth below, or what passes for it, is a violent and chaotic landscape, a molten inferno of bubbling lava and roiling clouds of toxic gases. This is no planet for life. It is barely a planet at all. A newborn world still in the throes of formation. The time traveler's heart pounds as they take in the apocalyptic scene. Vast rivers of molten rock snake across the surface, flowing into glowing orange lakes of magma. In the distance, massive volcanic eruptions puncture the airless sky, spewing ash and gas with an intensity that shakes the ground even from within the capsule. There are no continents, no oceans, no signs of stability. The air outside is a poisonous cocktail of carbon dioxide, sulfur dioxide, and methane, while temperatures are so high that even the thought of stepping outside is unthinkable. The traveler now understands why they were warned this early world might be inhospitable. Not even the most advanced protective suits could shield them here. For a paleontologist accustomed to piecing together fragments of the past, this living, breathing chaos is overwhelming. The time traveler had long studied the ancient rocks of Earth, imagining the world that must have existed when they were formed. Yet nothing could have prepared them for the raw power and sheer hostility of this primordial landscape. Suddenly, a flash streaks across the blackness. A massive asteroid blazing through the sky before slamming into the molten ground with a force that shakes the pod violently. The traveler grips the console, realizing they are witnessing one of the countless impacts that helped shape Earth in its earliest days. These collisions, they know, brought not only destruction, but also the seeds of creation, delivering the essential building blocks of water, minerals, and organic molecules that would one day give rise to life. But in this moment, the scale of destruction is staggering. The impact sends a plume of molten rock and dust shooting into the void, raining fire and ash down on the surrounding landscape. The traveler marvels at the resilience of the planet itself, slowly transforming under such relentless bombardment. Despite the hellish environment, the traveler can't help but feel a sense of awe. They know that this molten wasteland is the beginning of the Earth's long journey to becoming a cradle for life. Over the next billions of years, this fiery chaos will cool and stabilize. Oceans will form, the atmosphere will develop, and continents will rise. What seems like an uninhabitable inferno now is the foundation of a world that will one day teem with life. As the traveler studies the screen, contemplating their next move, they can't help but wonder, when will the Earth finally become a place where humans, or any kind of life, could survive? Could they bear witness to the first drops of liquid water pooling on the surface? To the creation of the earliest land masses? Or would even those times still prove too hostile? The traveler realizes that while they are safe within the capsule, they cannot stay here. The Earth of 4.5 billion years ago is magnificent, but entirely uninhabitable. It is time to move forward, to search for a more hospitable era, an Earth with water, an atmosphere, perhaps even the first stirrings of life. Adjusting the dials, they input a new date, millions of years ahead, and prepare for the next leap through time. As the engines power up again, the molten world outside begins to blur and distort, receding into a fiery haze. The traveler steadies their nerves, ready to face whatever comes next. This journey, after all, is about more than survival. It is about understanding how a barren, lifeless rock became the only home humanity has ever known. As the time traveler steadies themselves in the capsule, they are struck by the harshness of the scene outside. The Hadean Earth, still young and volatile, is a far cry from the blue and green world they know. The land beyond the capsule's curved glass windows is scorched and barren, a landscape of molten rock and jagged ridges glowing faintly orange against the dim, surreal light of the sun. Rivers of lava flow unceasingly, carving chaotic paths through a crust that is still thin and fractured. Volcanoes erupt with violent regularity, spewing plumes of ash and gas into a sky tinged faintly blue, but suffused with a fiery orange hue from the surface below. The traveler's instruments provide a grim reminder of the planet's hostility. Alarms shriek warnings of extreme heat, unstable terrain, and seismic activity. The capsule shakes slightly as distant impacts reverberate through the planet, likely from massive asteroids that still rain down on this unformed world, leaving fresh scars on its surface. Looking up, the traveler notes that the sky itself is unlike anything they've ever seen. The atmosphere is thin and alien, composed mostly of hydrogen and helium, with traces of methane and ammonia. It fails to scatter sunlight effectively, leaving the heavens dim even at midday. At night, this faint atmosphere would provide no protection from the stars' unfiltered light, or the harsh cosmic radiation that bathes the planet. Despite its fragility, the thin veil of gases swirls chaotically, pushed by the relentless heat rising from below. It carries with it noxious compounds that escape from the molten surface: carbon dioxide, sulfur dioxide, and even traces of hydrogen sulfide, creating a toxic cocktail that would render even the smallest breath lethal. The ground shakes once again, this time with more force, and a flash of light streaks across the sky. Another asteroid, glowing white-hot as it plummets through the thin atmosphere, slams into the planet with catastrophic force. The impact sends shockwaves rippling across the terrain, and a plume of molten debris rises into the sky before settling back into the fiery landscape. This is not an unusual event. The Hadean Earth is in the throes of the late heavy bombardment, a period when asteroids and comets relentlessly pummel the planet, delivering not only devastation, but also the raw materials, water, and organic molecules that will one day make life possible. Despite its hostility, there is an undeniable beauty to this chaos. The traveler gazes at the molten rivers, the glowing craters, and the volcanic plumes, marveling at the raw energy and transformative power at work. This is the crucible of creation, a planet forging itself from the ashes of stellar debris, preparing for the eons of change to come. For now, though, survival here is impossible. The traveler's instruments confirm what they already know. This is not a place for humans. Even within the capsule, insulated from the searing heat and poisonous gases, the traveler feels the weight of the environment pressing against the fragile seals that keep them alive. The traveler takes a deep breath of the cool, recycled air inside the pod and adjusts the controls for their next leap forward in time. This is only the beginning of Earth's story. For billions of years, this molten hellscape will cool and solidify, forming the crust that will one day host oceans, continents, and life. But for now, the planet is still young and wild, a place of relentless destruction and creation. With a flick of a switch, the engines power up once more, and the capsule begins to ascend through the violent haze of the Hadean Earth, carrying the traveler forward to the next chapter of the planet's history. As the time machine stabilizes in its new temporal position, the traveler takes a long, calming breath. The tumultuous chaos of the Hadean has been replaced by an entirely different landscape. Through the capsule's curved glass, they gaze out at a scene that is almost tranquil by comparison. A vast expanse of deep blue ocean stretches to the horizon, broken only by the occasional ripple of waves. The transition is startling. This is Earth, but it is now the Archean Earth. Some billion years after the fiery trials of planetary formation, and its transformation is breathtaking. The once barren and molten surface has cooled and hardened, giving way to a world dominated by water. There are no continents as we know them, only small, jagged proto-islands of volcanic rock peeking above the waves. The traveler's capsule bobs gently on the surface, its sensors providing vital data about the conditions of this nascent oceanic world. The temperature outside is strikingly warm, registering around 30 degrees Celsius, akin to the tropical climates the traveler left behind in the 21st century. It is a surprising revelation. With the young sun still dim and only 3/4 as luminous as it will eventually become, Earth's surface should be locked in ice. Yet the oceans are liquid, and the air is warm, a paradox that demands an explanation. The answer lies in the hazy, orange-tinged sky above. The atmosphere is dense and heavy, rich in greenhouse gases that trap the sun's heat with remarkable efficiency. Carbon dioxide and methane dominate this primitive atmosphere, creating a powerful insulating effect. Methane, released from the volcanic activity that still churns beneath the surface, plays a particularly crucial role. It is a potent greenhouse gas, far more effective than carbon dioxide at retaining heat, and its abundance compensates for the sun's relative dimness. The traveler, now cautious after their brush with disaster in the Hadean, uses the capsule's instruments to analyze the air and water without stepping outside. The results are fascinating. The oceans, vast and uninterrupted, are slightly acidic, with a pH akin to orange juice. This mild acidity stems from the carbon dioxide dissolving into the water, forming carbonic acid. While harmless to the traveler, this chemical composition will play a critical role in shaping Earth's future, influencing the formation of minerals and the eventual emergence of life. The sky itself is a blend of familiarity and alienness. While it bears the same hazy blue hue of modern Earth, the orange and gray overtones hint at its primitive makeup. Clouds of water vapor form towering structures, swirling and breaking apart in patterns dictated by the atmosphere's density and the planet's rapid rotation. There is no oxygen yet, no breathable air for the traveler. But nitrogen and other gases, alongside the greenhouse components, create a unique and evolving environment. Occasionally, faint glimmers streak across the sky. These are not meteors from the late heavy bombardment, but rather the remnants of smaller debris still finding their place in the young solar system. Unlike the relentless impacts of the Hadean, these occasional visitors are a sign of a planet settling into relative stability. While there are no fish, plants, or reefs to decorate these early oceans, they are far from barren. Beneath the capsule, the traveler's instruments detect the faint chemical traces of primitive life. Microbial mats of cyanobacteria clinging to the rocky substrates of the proto-islands. These simple organisms are among the first living things on Earth, quietly transforming the planet with their metabolic processes. By converting sunlight and carbon dioxide into energy, they produce oxygen as a byproduct, laying the groundwork for an atmosphere that will one day support complex life. The traveler marvels at this subtle but profound activity. The cyanobacteria are microscopic pioneers, shaping the world in ways that will only be understood billions of years later. The faint greenish tint on some of the volcanic rocks hints at their presence, a sign of life's tenacity and potential. The traveler reflects on the incredible transformation that has occurred in just 1 billion years. From a molten, inhospitable hellscape, Earth has become a world of water and burgeoning life. It is still far from being a home for humans, but the potential is unmistakable. The oceans are a cradle, nurturing the first steps of biological evolution. With a renewed sense of curiosity, the traveler adjusts the capsule's controls. This is only the beginning. Ahead lies the slow march of continental drift, the rise of oxygen, and the eventual explosion of complex life. The traveler can't help but wonder, how far forward must they go before the Earth becomes a place they could call home? With a flick of a switch, the capsule begins its next leap forward in time, leaving the Archean Earth and its primordial beauty behind. As the traveler peers out from their capsule, the Archean Earth reveals itself as a world of contrasts, both hauntingly alien and eerily familiar. Towering clouds cycle water vapor endlessly between the ocean's surface and the sky, their colossal forms scattering the sunlight into a soft, diffused blue. Yet the familiar daytime sky hides a lethal secret. The very air that cloaks the planet is devoid of life-sustaining oxygen. What fills the atmosphere instead is a mix of nitrogen, carbon dioxide, and methane, creating a world hostile to the traveler's existence. The traveler studies the readings from the onboard instruments. Nitrogen, as it does today, makes up the majority of the atmosphere, but the absence of oxygen is stark. Carbon-bearing molecules, particularly carbon dioxide and methane, occupy up to 15% of the air. These gases, though invisible, define the Archean world in profound ways. Carbon dioxide dissolves into the oceans, forming carbonic acid that gives the water its slight acidity. This process accelerates the chemical weathering of the ocean floor, where grains of sand and mud eroded from submerged volcanic ridges settle. The traveler notes that the ocean, though warm and inviting in appearance, is a place of constant transformation, a crucible where geology and chemistry intertwine. Meanwhile, the upper atmosphere is shrouded in a faint orange haze, the result of sunlight reacting with methane and carbon dioxide. These reactions create complex organic molecules, scattering light and tinting the sky. Though thinner and more diffuse than Titan's thick haze, it still dims the sunlight and gives the world an otherworldly glow. The paradox of the warm tropical climate, despite the faint young sun, puzzles the traveler no longer. Methane and carbon dioxide act as powerful greenhouse gases, trapping infrared radiation and insulating the planet. Without these molecules, the planet's surface would be locked in ice under the sun's still weak rays. Instead, the Archean Earth enjoys a balmy heat, its greenhouse effect providing a vital blanket of warmth. The traveler is struck by the delicate balance at play. These gases, though lethal to humans, are essential for maintaining the Earth's early warmth, setting the stage for the gradual emergence of life. As the sun sinks below the horizon, the endless ocean transforms under a star-filled sky. With no continents yet formed, there is no land in sight, only the vast, dark expanse of water. The traveler recalls that the rocks beneath the capsule are slowly forming, built from the grains eroded off submerged volcanic ridges. These are the ancestors of the most ancient rocks that will one day rise to the surface in Western Australia. But for now, they lie hidden in the ocean's depths. The ocean stretches in all directions, a realm of dark, crushing pressure. Though life stirs in the depths, microbial mats of cyanobacteria beginning to harness the sun's energy, their existence is humble and unnoticed in the grand scheme of the planet's evolution. Night brings its own wonders. The sky darkens, and stars blaze brilliantly, unimpeded by the haze that colors the day. The traveler marvels at the vibrant auroras that ripple across the heavens. Unlike the green auroras of modern Earth, these lights are vivid blues and reds, a signature of the nitrogen-rich, oxygen-poor atmosphere. Curtains of light cascade across the sky, a celestial dance that hints at the energetic forces shaping the planet. The endless ocean and the unbreathable atmosphere weigh heavily on the traveler. While the warm waters lap soothingly against the capsule, they cannot escape the realization that this world is still far from hospitable. The beginnings of life are stirring, but it remains a minor player in the planet's story. For all its potential, the Archean Earth is not a place they can stay. Adjusting the controls, the traveler sets their sights on a new era. Somewhere in the billions of years ahead, the air will change, continents will rise, and life will flourish. As the time machine hums to life, the traveler takes one last look at the serene but alien ocean before disappearing into the stream of time, chasing a future where survival might finally be possible. The traveler adjusts the dials of the time machine and prepares for another leap, this time to a transformative period in Earth's history, the Paleoproterozoic era. Targeting the era of the Great Oxidation Event some 2.4 billion years ago, they reflect on the incredible parallels between the Perseverance rover's MOXIE experiment and the natural processes that began reshaping Earth's environment billions of years earlier. With a hum of energy, the capsule begins its descent into the past, racing back toward the time when life fundamentally altered the planet's atmosphere. As the time machine settles into its destination, the traveler surveys the primitive Earth. The planet is still starkly alien. There are no forests, no animals, and no land-dwelling organisms of any kind. Instead, the surface is dominated by lifeless rocks and endless, shallow oceans. The air, thick with volcanic gases, is a stifling mix of nitrogen, methane, and carbon dioxide, but crucially, no oxygen. For nearly 2 billion years, life has clung to the deep ocean's thermal vents, thriving in isolated pockets where heat and minerals provide the necessary energy for survival. These chemotrophic microbes build intricate layered communities, known to modern scientists as stromatolites. These structures consist of stacked microbial mats, where each layer relies on the metabolic byproducts of the one below, creating a primitive but efficient ecosystem. However, their reach is limited. These life forms cannot expand beyond the narrow, energy-rich zones of volcanic activity. Then, a revolutionary innovation changes everything. Deep in the sunlit waters, certain microbes evolve pigments that enable them to capture sunlight. This evolutionary breakthrough gives rise to photosynthesis, allowing microbes to harness the sun's energy directly. These pioneering organisms, the ancestors of cyanobacteria, transform the abundant carbon dioxide in the atmosphere and water in the oceans into energy-rich sugars. The byproduct of this reaction is a gas that will become central to life's future on Earth: oxygen. As photosynthetic microbes spread across Earth's shallow oceans, they begin pumping oxygen into the water, a feat as monumental as any technological advancement in human history. For the first time, Earth's oceans and atmosphere are enriched with this reactive gas. At first, the oxygen quickly bonds with dissolved iron in the oceans, forming rusty deposits that sink to the sea floor. Over millions of years, these reactions create the banded iron formations found in ancient rocks today. Valuable clues to this transformative period. Eventually, the oceans become saturated with oxygen, and it begins to escape into the atmosphere. This marks the dawn of the Great Oxidation Event. The traveler watches as the planet's air slowly transitions, the skies losing their earlier hazy orange tint as oxygen accumulates. The oxygen doesn't just change the composition of the atmosphere, it transforms the planet itself. Oxygen is a highly reactive gas, and its introduction triggers a cascade of chemical reactions across Earth's surface. Rocks are oxidized, creating the red, rusty hue seen in ancient soils. Methane, a potent greenhouse gas that has long warmed the planet, reacts with oxygen, causing a dramatic cooling effect. The planet teeters on the edge of its first major ice age. The sudden presence of oxygen is both a blessing and a curse. While it enables more efficient metabolisms and paves the way for the evolution of complex life, it is toxic to many of the anaerobic organisms that once dominated Earth's biosphere. For these life forms, oxygen is a deadly poison. Many are driven to extinction, while others retreat to oxygen-free niches, such as deep sediments or the guts of future multicellular organisms. This great die-off is one of the first mass extinctions in Earth's history. At the same time, the stage is set for life's next great leap forward. Oxygen opens up new possibilities for metabolism, enabling the evolution of larger, more complex organisms. In time, the oxygen-rich atmosphere will also form a protective ozone layer, shielding the surface from harmful ultraviolet radiation and allowing life to venture onto land. Inside the safety of the capsule, the traveler marvels at the unfolding drama outside. The transformation of Earth's atmosphere by these ancient microbes is not unlike the MOXIE experiment on Mars, albeit on a far grander scale. What took humans decades of research and engineering to achieve, extracting oxygen from an alien environment, these microbes accomplished through the blind ingenuity of evolution. The traveler records their observations, realizing that this singular event, the Great Oxidation, is the foundation for all complex life, including their own. Without this natural feat of terraforming, Earth might have remained a planet dominated by microbial mats and methane haze. The realization is humbling. As the time machine's controls hum to life again, the traveler sets a new target date. Their journey through Earth's past is far from over, but they now understand more deeply how the simplest organisms can leave the most profound legacy. Oxygen, once a byproduct of microbial life, will become the breath of civilizations yet to come. As the traveler peers out of the time machine's frost-rimmed windows, a slow but perceptible transformation begins to take shape across the frozen expanse. The icy world of the Huronian glaciation is gradually giving way to more dynamic and colorful landscapes. It is now 2.2 billion years ago, and the traveler observes the first signs of geological rejuvenation. As mountains are thrust skyward, their jagged peaks painted in hues of iron-rich red, while vast ice sheets retreat in fits and starts. Erosion and weathering smooth the newly formed ridges, depositing sediments into the shallow seas that are finally beginning to thaw. The thawing of Snowball Earth was not a sudden event. Over hundreds of millions of years, the Earth's internal forces pushed against the icy grip of glaciation. Volcanoes, impervious to the cold above, erupted with force, spewing vast quantities of carbon dioxide into the atmosphere. With less methane to react with and bind it into other compounds, this carbon dioxide began to accumulate. Slowly but surely, the greenhouse effect resumed its work, trapping the sun's faint heat and warming the planet. The traveler marvels at the evolving atmosphere, watching the readouts in their capsule as the composition of gases fluctuates. The percentage of carbon dioxide rises, nudging global temperatures upward. Ice sheets crack and fracture, exposing dark land masses that absorb sunlight and amplify the warming process. Meanwhile, photosynthesizing microbes continue their relentless production of oxygen. Although this waste product had previously contributed to global cooling by depleting greenhouse gases, it now begins to accumulate more steadily in the atmosphere. The traveler notes with interest the way oxygen levels oscillate, rising and falling with the cycles of life and extinction that continue in the shallow seas. This plateau, the traveler realizes, is a prelude to something greater. While oxygen levels are still not high enough to breathe, the slow increase suggests that life is finding new ways to adapt and thrive. The traveler reflects on the irony. The same process that led to the catastrophic Huronian glaciation is now driving the conditions for its eventual end. The oxygenation of the atmosphere is not only a byproduct of photosynthesis, but a herald of Earth's next great chapter. Outside the time machine, the traveler sees the transformation accelerate. Where once there was only ice, shallow seas now sparkle under the dim light of the young sun. The retreating glaciers expose vast stretches of rocky ground, which are soon covered in sediments, washed down by rivers fed by melting ice. Layers of sandstone and shale begin to build, and the first signs of complex sedimentary structures appear. The Earth's surface takes on a rusty hue as iron-rich rocks oxidize in response to the increasing presence of atmospheric oxygen. This red coloration, the traveler knows, will one day be found in ancient banded iron formations, preserved as evidence of this transformative era. Despite the thaw and the beauty of the unfolding landscape, the traveler remains acutely aware of their own predicament. The capsule's instruments confirm what the traveler already suspects. The air outside is still unbreathable. Oxygen levels hover around 5%, tantalizingly close, but still far too low to support anything more than microbial life. Frustrated but undeterred, the traveler contemplates their next move. Should they push further forward in time, risking another ice age or cataclysm? Or should they linger here, trying to better understand the slow, rhythmic dance of life and geology that is sculpting this ancient world? As they consider their options, the traveler notices something remarkable in the data being collected. The oceans, once lifeless except for the simplest of microbes, are now beginning to teem with more complex forms of life. While still microscopic, these early eukaryotic cells, with their nuclei and organelles, represent a significant leap forward in evolution. This is a sign that Earth's biosphere is on the cusp of diversification, laying the groundwork for the incredible explosion of life yet to come. The traveler decides to take one last look at this Paleoproterozoic world before setting a new target. They step back from the controls, letting the time machine idle as they record their observations. The journey so far has been harrowing, but it has also revealed the resilience of life and the delicate balance of planetary processes. With a deep breath, they reach for the controls once more. The great oxidation event has set the stage, but the traveler knows that the true story of life's emergence is only just beginning. They set their sights on a time when the Earth's atmosphere might finally be ready to support more than just microbes, hoping that their next leap will bring them closer to the vibrant, living world they seek. The traveler steadies themselves on the rocky ground, their boots crunching against the gravelly surface. Each breath is a reminder of how far they've come. Through epochs of barren desolation, suffocating atmospheres, and endless oceans devoid of visible life. Now, at last, they stand under a sky filled with breathable air, on a planet visibly teeming with potential. It feels surreal to touch the ground and see the hints of greenery staining the shoreline, knowing this was once an unimaginable future for Earth. The traveler gazes out at the sprawling shoreline. The waters shimmer under a pale sun, reflecting a mix of blue and green that seems alive with microbial activity. This isn't the vibrant, bustling planet they left behind in the modern era, but it's a marked improvement from the blackened seas and sulfurous skies of the boring billion. The air feels slightly heavier than they're used to, humid and warm, with the faint tang of salt and a subtle edge of organic decay. The smell is reminiscent of a tidal flat after the retreating tide, a medley of life and death in the making. The rocks beneath their feet bear the unmistakable signs of life's growing foothold on land. Delicate algal mats have spread across the damp surfaces, creating a slimy green film that glistens in the sunlight. These primitive photosynthesizers are pioneers, laying the groundwork for ecosystems that will one day dominate the planet. The traveler marvels at the resilience of these early colonizers, their ability to withstand the harsh UV radiation from the sun and the relentless battering of tides. They are reminded of the fossilized traces they studied back home, ripples and wrinkles left by organisms just like these, frozen in stone as a testament to this critical chapter in Earth's history. The traveler's attention is drawn back to the capsule, where the atmospheric monitor displays a reading they've been hoping to see for eons. Nearly 20% oxygen. This concentration, coupled with a drop in methane and hydrogen sulfide, marks a turning point in Earth's atmospheric evolution. For the first time in billions of years, the atmosphere has reached a state capable of supporting more complex life forms. This is the Neoproterozoic Earth, primed for the dramatic evolutionary leaps yet to come. The rise in oxygen has been driven by the incredible efficiency of photosynthesis, which has finally reached a global scale. Cyanobacteria, algae, and other photosynthesizing organisms have proliferated across the oceans, releasing oxygen into the atmosphere in unprecedented quantities. This oxygen revolution is transforming not only the air, but also the chemistry of the oceans. Iron and other minerals, once dissolved in the water, are oxidizing and settling out, creating deposits that will be studied by future geologists as banded iron formations. Carefully pacing themselves to avoid overexertion, the traveler ventures further from the capsule. Each step feels like a leap through time, a connection to the earliest days of multicellular life. In the shallows of the shoreline, they spot something extraordinary. Clusters of larger, more complex organisms. These are not yet animals, but colonies of cells working together, sharing resources and signaling to one another in ways that hint at the first steps toward true multicellularity. Kneeling by the water, the traveler examines the gelatinous masses. These simple organisms may look unassuming, but they represent a revolution in evolution. Cooperation between cells is a game changer, enabling specialization and paving the way for the diversity of life that will eventually populate the Earth. They feel a swell of wonder and gratitude, knowing that these humble beginnings will one day lead to everything from towering redwoods to leaping gazelles and even themselves. Despite the progress, the traveler knows this is just the beginning of the Neoproterozoic. Ahead lies a world-changing event, the cryogenian glaciations, where the Earth will once again freeze over in a dramatic Snowball Earth episode. But unlike the deep freeze of the Huronian, this one will set the stage for the Cambrian explosion, a burst of biodiversity that will forever alter the trajectory of life on Earth. For now, the traveler chooses to linger, absorbing every detail of this transformative era. They are surrounded by a world on the cusp of change, a planet where the groundwork for all future life is being painstakingly laid. As they breathe in the ancient air, rich with the history of Earth's struggle and triumph, they feel an overwhelming connection to the past and an unshakable curiosity for what lies ahead. Standing at the edge of a primordial sea, the traveler gazes out at a horizon that holds both the memories of Earth's distant past and the promise of its astonishing future. This is a moment to savor, a rare pause in the relentless march of time, a snapshot of a world becoming something new. The time-traveling paleontologist sits back in their seat, letting the rhythm of the machine's movement and the blur of passing millennia guide their thoughts. Ada Blackjack's incredible story of resilience echoes in their mind, a testament to human ingenuity and survival instincts in the harshest of conditions. But as the paleontologist considers their own position, Ada's challenges pale in comparison. At least she had a breathable atmosphere, food to hunt, and water to drink. The paleontologist faces a more fundamental problem. Earth itself has not yet become fully habitable for humans. For a human to survive anywhere, certain elements are non-negotiable. Oxygen is the first and most obvious requirement. Without it, no amount of ingenuity, adaptability, or technology can sustain life. Thankfully, the traveler has finally reached a point in Earth's history where oxygen is plentiful enough to breathe. The next hurdle is temperature. The human body can only function within a relatively narrow range of temperatures. Too cold, and metabolic processes slow to a dangerous crawl. Too hot, and dehydration and heat stroke become lethal. Water is the next essential. Though the Earth's oceans have existed for billions of years, not all water is safe to drink. Early oceans were acidic, salty, and filled with dissolved minerals and organic compounds that could wreak havoc on human physiology. Even now, standing at the edge of a Neoproterozoic ocean, the paleontologist knows the water is likely unfit for human consumption. Finally, there is food, perhaps the most complex necessity of all. Early Earth's ecosystems were dominated by single-celled organisms, algae, and primitive plants. Without advanced digestive systems capable of breaking down cellulose or other tough organic compounds, humans cannot derive much nutrition from these early life forms. Moreover, the absence of large, protein-rich animals or edible seeds means the traveler would need to invent entirely new methods of sustenance to survive in this alien time. As the paleontologist reflects, they realize that survival is not just about meeting the basic needs of air, water, and food, it's also about adaptability. Earth's environments are in constant flux. Even now, as they traverse the Neoproterozoic, the traveler is aware of the storm building over the ocean, a reminder that the planet's volatile weather can turn hospitable conditions into death traps in an instant. Unlike Ada Blackjack, who had the stability of a single location to adapt to, the traveler must contend with a dynamic planet where continents drift, climates shift, and ecosystems evolve. The thought is daunting, but it also sparks a new sense of curiosity. What if humans could follow these changes, learning to adapt to Earth's evolving environments over geological time? The traveler's musings turn practical. How could they, or anyone, survive in the deep past of Earth? A few ideas begin to take shape. The first is mobility. Like early human nomads, the traveler realizes they must stay on the move, following habitable conditions wherever they emerge. The time machine, it seems, is their ultimate survival tool, providing not only shelter, but the ability to escape uninhabitable conditions entirely. Second, they consider technology. Modern humans have long relied on tools to bridge the gap between natural limitations and environmental demands. Could the traveler create filters to purify water, harness solar energy to generate heat or electricity, or even cultivate edible microorganisms to produce food? The possibilities are tantalizing, but also intimidating. Without the resources of their own era, even the simplest tools would require immense ingenuity to manufacture. Lastly, the traveler thinks about community. Human survival has always been a collective effort. The thought of returning to the past with a team of specialists, engineers, biologists, and survivalists is an appealing one. Together, they could pool their knowledge and skills to tackle the challenges of deep time. As the storm on the horizon begins to encroach, the traveler feels a pang of unease. The time machine, sturdy as it is, may not withstand the full fury of the Neoproterozoic weather. Reluctantly, they retreat back into the capsule, sealing themselves inside just as the first gusts of wind whip across the beach. From the safety of the pod, the paleontologist watches as sheets of rain lash the shore, reducing the verdant algae mats to a churned mess of foam and muck. It's a stark reminder that even in this relatively habitable era, Earth is far from a comfortable home. And yet, there is a strange beauty in its rawness. in the untamed power of nature as it shapes the planet for the life forms yet to come. The paleontologist's journey is far from over. They still hope to find a time when Earth can fully support human life. But they are beginning to realize that survival in deep time is not just a matter of meeting basic needs. It's about understanding and respecting the planet's natural rhythms, about finding a balance between adaptation and innovation, and about appreciating the resilience of life in all its forms. With a final glance at the storm-racked landscape, the traveler adjusts the controls and sets a new destination. The past holds many more secrets, and they are determined to uncover them all. After all, survival isn't just about enduring. It's about thriving, learning, and pushing the boundaries of what's possible. Charles Doolittle Walcott's discovery in the Burgess Shale marks one of the most significant fossil finds in history, providing a window into a world teeming with life from over 500 million years ago. The Burgess Shale, located high in the Canadian Rockies, preserves creatures from the Cambrian explosion, a period of unparalleled evolutionary innovation that followed the Ediacaran era. This discovery revealed not just the diversity of life, but also the complexity of ecosystems that had emerged. A testament to the Earth's capacity for dramatic biological change. The paleontologist aboard the time machine has now resolved to witness this explosion of life firsthand. After leaving behind the strange quilted bodies of the Ediacaran biota, they adjust the dials to leap forward just a few million years to the early Cambrian. What greets them is a world transformed. The air, warmed by an increasingly bright sun and enriched with oxygen, is now far closer to breathable. Shallow seas stretch out in all directions, teeming with activity and energy that is immediately visible even from within the capsule. Upon stepping out onto the shore, the traveler is struck by the vibrant hues of this new world. The clear, shallow waters reveal creatures of every size and shape, darting, scuttling, and drifting along the seabed. Schools of tiny, shrimp-like animals flash silver as they move in synchrony, while larger, segmented creatures plow furrows into the sand. The paleontologist marvels at the sight of trilobites, armored, many-legged arthropods, crawling across the ocean floor in organized lines, their segmented bodies glinting in the sunlight. Kneeling at the water's edge, the traveler is captivated by a scene of predation. A sleek predator, Anomalocaris, with its large, grasping appendages, swoops down to snatch a smaller, shelled creature. This marks a striking difference from the passive Ediacaran fauna. Here, competition and aggression define survival, and the ecosystem pulses with an energy that is both thrilling and unnerving. As the traveler surveys this thriving ecosystem, they reflect on the role of fossil preservation in revealing such ancient secrets. The Burgess Shale owes its exceptional preservation to a unique set of geological conditions. The animals that lived in these Cambrian seas were buried quickly in fine sediment during underwater landslides, which prevented decay and scavenging. Over millions of years, the mud compressed into shale, encasing the delicate soft tissues of creatures that would otherwise have vanished without a trace. It's this remarkable preservation that allowed Walcott and later scientists to reconstruct a vivid picture of life in the Cambrian. Here were creatures unlike anything alive today: Hallucigenia, with its spiky legs and worm-like body; Opabinia, with 5 eyes and a flexible proboscis; and Pikaia, an early chordate that offers a glimpse of the evolutionary lineage leading to vertebrates. For the paleontologist, the Cambrian offers a world far more hospitable than the barren Ediacaran. Food is abundant. Trilobites, small mollusks, and other soft-bodied creatures could easily provide sustenance. The shallow coastal environment also offers natural shelter in the form of rocky overhangs and tidal pools. With simple tools and ingenuity, this era could sustain human survival, though the traveler acknowledges the ethical quandary of interfering with such a delicate and ancient ecosystem. Looking deeper into the tidal pools, the traveler is drawn to the translucent forms of jellyfish-like creatures drifting near the surface. Unlike the rubbery Ediacaran biota, these animals are mobile and seemingly more aware of their surroundings. Crustacean-like creatures scuttle along the seabed, using their specialized appendages to dig into the mud for food. The traveler begins collecting samples, shell fragments, small mollusks, and pieces of kelp-like algae for closer examination back in the capsule. But as they work, they're reminded of the fleeting nature of this moment in Earth's history. Just as the Ediacaran biota gave way to the Cambrian explosion, so too will these creatures evolve or vanish over the millennia to come. Before returning to the time machine, the traveler pauses to take in the scene one last time. The Cambrian is a period of abundance and innovation, but it's also a reminder of life's fragility. Mass extinctions are an inevitable part of Earth's history. And even the most successful species are not immune to environmental change. As the paleontologist sets the dials for their next destination, they are filled with a profound sense of gratitude for the interconnected web of life that has endured through eons of upheaval. The Cambrian explosion is more than just a chapter in Earth's history. It is a testament to the resilience and creativity of life itself. A burst of evolutionary brilliance that paved the way for everything that followed. The traveler marvels at the transformation of the Earth's surface over these eons, witnessing the steady march of life from the shallow seas onto land and the profound changes it brings. As they move through the Devonian period, they see the rise of the first true forests. Towering ferns and tree-like plants, such as Archaeopteris, dominate the landscape, their deep roots stabilizing the soil and creating vast networks of nutrient-rich sediment. These primitive trees are not only reshaping the terrain, but also altering the atmosphere, drawing down carbon dioxide and contributing to the creation of a more temperate climate. The Devonian is also known as the Age of Fishes, and the traveler is drawn back to the water's edge to see this new explosion of biodiversity. The oceans teem with armored placoderms, such as the formidable Dunkleosteus, a predator equipped with sharp, slicing jaw plates. Smaller bony fish dart among the shallows, while early sharks patrol the deeper waters. Coral reefs, complex and sprawling, provide shelter for a host of marine organisms. Life has diversified in remarkable ways, building ecosystems that are more intricate and interdependent than ever before. On land, the traveler notices the first appearances of creatures venturing beyond the water. Early tetrapods, like Tiktaalik, are experimenting with life at the water's edge. These pioneering animals, with their limb-like fins, are the first steps in the evolution of vertebrates that can fully inhabit terrestrial environments. The traveler imagines these creatures awkwardly dragging themselves onto muddy banks, their adaptations paving the way for future terrestrial dominance. Continuing forward, the time machine slows at the Carboniferous period, roughly 300 million years ago. Here, the world is a lush, green paradise dominated by vast, swampy forests. Giant lycophytes and horsetails grow in dense thickets, their trunks rising to impressive heights. The humid climate fuels explosive plant growth, creating extensive coal-forming forests that will later give this period its name. The traveler steps out into this steamy, oxygen-rich world and feels an immediate difference. The atmosphere, now composed of nearly 30% oxygen, allows for the evolution of massive insects. Dragonflies the size of seagulls, such as Meganura, glide gracefully through the air, while millipedes like Arthropleura stretch to lengths of up to 2 meters, crawling through the dense undergrowth. The traveler is both awed and unsettled by these gargantuan arthropods, marveling at the evolutionary possibilities of this high-oxygen environment. The swampy terrain, while teeming with life, presents challenges for survival. The traveler reflects on the lack of large animals to hunt for sustenance, as the dominant vertebrates are still amphibians confined to water or damp habitats. Building shelter in this waterlogged environment would also be difficult, as much of the wood is water-saturated and prone to decay. Despite its verdant beauty, the Carboniferous presents formidable challenges to long-term human habitation. Knowing the story of life's relentless march forward, the traveler prepares to leap into the future once again, eager to see how these early forests and giant insects will give way to new forms of life and ecosystems. They adjust the dials, setting their sights on the next great chapter of Earth's history, the age of reptiles and the dominance of the dinosaurs. Emerging from the dense gymnosperm forests of the Carboniferous and into the vibrant, flower-filled landscapes of the late Mesozoic, the traveler finds themselves in a transformed world. It is the middle of the Cretaceous period, roughly 120 million years ago, and the once monotonous greenery of conifers has been replaced by a riot of colors and scents. Angiosperms, or flowering plants, have taken root across the land, introducing a revolutionary new approach to reproduction and survival. These plants have evolved flowers to attract pollinators and fruits to entice animals, who in turn spread their seeds far and wide. For the traveler, this evolutionary leap represents something more immediate: a wealth of accessible and nutritious food. The fruits hanging from trees and vines are soft, sweet, and bursting with the carbohydrates and vitamins needed to sustain. After eons of subsisting on undigestible algae or protein-rich but nutritionally incomplete marine life, the traveler can now enjoy a balanced diet. In addition to the fruits, flowering plants have brought other gifts to this ancient ecosystem. Grains and seeds, precursors to staples like wheat, rice, and corn, are beginning to take shape in the plant world. Though they remain a distant promise of the agricultural revolutions to come, the traveler gathers and samples what they can, reveling in the newfound abundance of food options that offer both energy and nourishment. Around them, the Cretaceous landscape teems with life. Birds like Geholornis flit between the branches, feasting on the same fruits as the traveler. Their sleek forms and colorful feathers suggest an advanced stage in avian evolution, and their behaviors hint at a deepening partnership with the flowering plants they help pollinate and propagate. Larger animals roam the plains and forests too, including dinosaurs that coexist alongside this rapidly diversifying flora. The traveler observes herbivorous dinosaurs grazing among the plants, their diets now enriched by the tender leaves and fruits of angiosperms. Meanwhile, predators like Tyrannosaurus rex lurk in the shadows, their sharp senses attuned to the movements of these plant-eating giants. The ecosystems of the Cretaceous are more complex and interconnected than anything the traveler has seen before, with flowering plants at the heart of this evolutionary web. The traveler is struck by how these plants have not only reshaped the land, but also influenced the behavior and evolution of animals. The co-evolutionary relationship between flowering plants and their pollinators or seed dispersers demonstrates nature's intricate balance and the power of mutual adaptation. It is a reminder of the interdependence that underpins all life on Earth. As the traveler moves through this lush environment, they note how the angiosperms have also begun to change the climate. By drawing down carbon dioxide through photosynthesis and stabilizing soils with their roots, these plants contribute to the regulation of Earth's atmosphere. The air is fresher, the climate more temperate, and the landscapes more inviting than ever before. For the first time in their journey through Earth's history, the traveler feels a sense of home. They find shade under the broad leaves of a flowering tree, savoring a piece of fruit and gazing out over the vibrant, thriving ecosystem. It is a world on the brink of modernity, laying the foundation for the habitats and resources that humans will one day rely on. Though their time in the Cretaceous is limited, the traveler knows that the seeds of the future have been planted, both figuratively and literally. The angiosperms that now dominate the landscape will continue to diversify and spread, shaping the course of evolution and creating the conditions for the rise of mammals, primates, and eventually humans. And with that thought, they prepare to make their next leap forward, eager to see the culmination of Earth's long and extraordinary story. Belonging to the angiosperms, flowering plants, these ancient flora revolutionized the ecosystems of Earth with their seeds encased in fleshy ovaries. These modifications evolved in an astonishing variety of forms, designed to attract animals and ensure successful dispersion and germination. For humans, these fleshy fruits and carbohydrate-rich parts of angiosperms became a vital, digestible food source. Unlike the tough, nutrient-scarce gymnosperms that had dominated earlier eras. Though their fossil record dates their emergence to roughly 140 million years ago in the early Cretaceous, angiosperms quickly rose to prominence. By 120 million years ago, as the fossilized diet of Geolornis suggests, these plants had cemented their role in the food web. This flourishing world of angiosperms is where the traveler finally finds themselves. Their time machine, silent and coated in a fine layer of dust, sits quietly in the shade of towering ancestral trees. Its display reads the late Mesozoic, a time when dinosaurs roamed the Earth in unparalleled diversity. The land is alive with activity. Frilled triceratops graze in herds, ankylosaurs lumber heavily through the undergrowth, and small mammals scurry from burrows, wary of the theropod predators lurking in the shadows. Primitive birds, like Geolornis, dart between branches, gathering fruits and seeds from the flowering plants that have reshaped this landscape. Among these ancient beings, the time traveler, now fully adapted to this world, gathers their daily sustenance. The angiosperm fruits, rich in carbohydrates and flavor, complement their diet of seafood and meat, which they have honed the skills to catch and prepare. The traveler has also built a simple but secure shelter at the forest's edge, where the plains stretch out, dotted with the majestic figures of herbivorous dinosaurs. Here, for the first time since beginning their journey through time, they have all the essentials for survival: food, water, breathable air, a comfortable temperature, and adequate shelter. Looking back on their journey, the traveler reflects on the long and arduous path that brought them here. They first encountered water in the Archean, but it was uninhabitable. Breathable air emerged only billions of years later during the Neoproterozoic. They found protein in the Cambrian seas, but lacked balance in their diet. True shelter only became possible in the Carboniferous when towering plants created shaded havens. And yet, it wasn't until the mid-Cretaceous, just 100 million years ago, that all the elements of survival came together in one place and time. The traveler considers the paradox of their experience. The Earth has always been a planet teeming with potential. Yet it took billions of years of evolution and planetary change to create a world where a human could thrive. Is it a testament to the fragility of modern humans, so finely tuned to the environments of their own time? Or is it a reflection of the dramatic, ever-changing nature of Earth itself? Perhaps it is both. For now, these questions can wait. The traveler, no longer a mere observer, but a part of this ancient world, embraces their role as a settler in this prehistoric paradise. With every breath of oxygen-rich air, every bite of sweet fruit, and every night spent under the Cretaceous stars, they live a life of unparalleled connection to Earth's extraordinary history. And so, the journey ends here, in a land of dinosaurs and flowering plants, in a time both ancient and vibrant. This is the earliest point in Earth's history where a human could survive and thrive. And for the traveler, it is home. Snowball Earth is a stark reminder that our planet's climate is anything but stable. Climate changes have shaped Earth's history, and they could shape our future too. If another global ice age were to happen, how would humanity respond? Could we adapt, or would we suffer the same fate as countless extinct species? Let me know your thoughts in the comments. And if you enjoyed this video, don't forget to like, share, and subscribe for more fascinating stories about Earth and the universe.